Okay guys, today we're going to be looking at confidence interval proportions. So essentially it's the same as the confidence intervals with the mean. The only difference is instead of having a mean b, you're going to have a proportion. So the information that is actually on your formula sheet is this one here. So that's on your SAPSA formula sheet. So you'll get that in the exam. And again, most of the formulas on there are for the 95% confidence interval. So the only thing that will change, if it has to change, will be the value there, the 1.96. So you'll certainly change that if you need to. So keep in mind that can change depending on what the confidence interval is for that. Now, obviously this is your sample portion, okay, and so therefore that's what we're looking at there is the proportion. So we're looking at how that may vary either side of the proportion for that. Let's just talk through a example in your textbook. All right, so hopefully that will make sense. I don't know why that thing's in the way. Okay, so here what we've got is a random sample of 200 South Australians. 76 support the Adelaide Crows AFL team. Find the proportion of Crow supporters from that. So all you have to do to find the proportion is simply divide 76 by 200. And that will give you 38% of the South Australian are estimated to be Crow supporters. So that's your first part. Then we want to find the 95% confidence interval for the proportion of South Australians who support the Crows. So then all we do is we go through and we put that information into our formula. So obviously our 38 is our sample portion. And then obviously if my P is equal to 0.38, then my Q or my one take P is equal to 0.62, and N is the number of supporters that or number of people we're surveying. So we put that into our calculator, and I'll show you how to do that later on. And we get a proportion between 31.27% and 44.76%. So what that means is the true proportion of people in South Australia who support the Crows with a 95% confidence interval is somewhere between 31.3% and 44.7%. Okay, so that's the idea of what we're doing there. Let's just go through this example just to try and show you how you do that on the calculator and the thinking behind that. So the first thing here is we've got a Transport Authority of Australia conducting a survey of motor vehicle accident deaths. So they found that 56 out of the 173 drivers tested positive to having high levels of drug or alcohol in their blood. Estimate with a 90% confidence interval the true percentage of deaths in Australia where drivers had high levels of alcohol or drugs. All right. So the one thing that we do need to know is obviously the 90%. Now that's going to be equal to 1.645. All right, so keep that in mind. And then when we're looking at our p-value is going to be 56 out of 173, and that's actually going to be equal to 0.324 if you do that. So that means my one take p, which is equal to my q value, and that's going to be equal to 0.676. Alright, so keep that in mind. So when we put this into the formula, it's going to be simply 0.324 take away. Now my proportion is 1.645. That's all over the square root of 0.324 times by 0.676, and then that's all over the sample size, which is how many people? 173 drivers. And then that is going to be greater than, so P, and then you're going to have the same thing again, but we're going to obviously put the plus there. Okay, so maybe for this particular example, I'm better write it out. Okay, 24. And that's going to be plus, and we'll put that thing down the bottom here, okay, because I've run out of space, 0.324. So if you want to show, you can use the formula. Certainly this is what you write down. Are you going to work this out by using the long method. No way. I'm going to show you how to do it in your calculator. Alright, so what you need to do is press your start button. We're going to go across to the test, and we're going to come down to a 1 prop z int. Okay, 1 prop z interval. So then what you're going to do is you're going to put down your x value. The sample size is in fact 56. You're going to put down the total number of people in the sample, which is 173, and then you're going to type in your confidence interval is 0.9. Alright, and then you're going to go calculate that, and that will give you a value of something like 0, it's 26, 52, and 38, 22. So when you come back over here, all you need to do is you need to write those values down. Sorry, back to the wrong one. So therefore what we can write down here is my proportion is greater than 0.22, no sorry, it's 26. So it's greater than 2652, and it's less than 0.3822. So therefore I can be 90% confident that the proportion of accidents caused by so either drugs or alcohol lies between 26.52% and 38.2%. So looking at your confidence level, obviously if my confidence interval increases, then what's going to happen is that range of percentages is going to increase. So I can be 90% confident that the portion of accidents caused by drugs or alcohol lies somewhere between 26.52 and 38.22%. Alright, so that's a sort of question that you'll need to answer using proportion. So whether it's proportional, whether it's a mean value, you're using your calculator, you write it into the formula, and then you write down your answer. Okay, so it's pretty simple. Have a go at those questions in that exercise, and catch up with me if you need some help.